रिस्पॉन्स आया है। मैंने उनसे जो बात की थी तो उन्होंने मांगा है ये लिस्ट ऑफ कॉन्ट्रैक्चुअल ऑफिसर्स। आपको हम सुन नहीं सकते ना।
सर आप म्यूटेड है।
Oh, can you hear me now?
Yes.
Oh,
Yes, sir.
सबको मेरा नमस्कार।
नमस्ते।
अच्छा, अनिर्बान, is the YouTube on?
Yes.
Just I'll come back in one minute.
है? हाँ ठीक है, बैठो आराम से। संतोष को भी कह दो जुड़ जाए।
Anirban, are you able to hear me?
Yes, sir. Yes, you are audible.
Okay, because there was problem last time, so I want.
नमस्कार सर।
Thank you.
नमस्कार सर।
So some people are joining. Let's wait for 2 minutes more and then we start.
Okay.
Let us start now. So I hope some more people will join as we proceed, but let us start on time. And to begin with, I would like to request Professor Ajay Ghatak, who is a renowned physicist and presently President of the National Academy of Sciences, India, to start the program, declare it open, and also to welcome everyone present on the occasion of our 76th Independence Day, or in other words, 75 years of independence. So I request Professor Ghatak to.
I want to share my screen. You have disabled. Can I share my screen?
Just a minute. Now you can do it.
Can you see my slides?
Yeah.
Okay. Thank you very much, Anirban. And this idea is of Professor Manju Sharma, who it was very extremely nice of her to suggest that we organize a short program today. So on behalf of our academy, I welcome you all on our Independence Day. And yesterday, our academy was decorated like this. And this photograph is courtesy of Dr. Neeraj Kumar. So as we celebrate the 75th year of independence, Azadi Ka Amrit Mahotsav, we must remember our great leaders with tremendous respect who sacrificed everything for the freedom, Mahatma Gandhi and many, many, many others. We must also remember thousands of freedom fighters who sacrificed their lives. And we should also remember hundreds of thousands of ordinary citizens of India who left their homes, their relatives, gave up everything to fight for our freedom, which we take for granted today. This is the Salt March. This is the Quit India movement and many other such occasions where hundreds of thousands of ordinary citizens came to the street and fought for our freedom. We should also remember thousands of ordinary citizens of India who were lined up like this and probably executed. And we should also remember our brave Jawans who are still fighting on our borders. So going over to the development of science education in India, we should mention that the first institution, as you all know, was the Presidency College, which was opened on 20th January 1817. Raja Ramohan Rai, along with 6 others, donated their personal wealth to establish the college. And the pioneering discoveries of Jagadish Chandra Bose and of Prafulla Chandra Ray were made in the laboratories of Presidency College. And then came colleges like Agra College, which was founded in 1823 by Pandit Gangadhar Shastri and is the oldest institution of learning in northern India. And I'm very proud that I studied in that college. Then came 3 great universities in Bombay, Calcutta, Madras. And then in 1869, Dr. Mahendralal Sarkar wrote that the prevailing backwardness of the country was due to backwardness of science. And the solution was in the vigorous pursuit of the sciences by original research. And this is true even today. And he started the Indian Association for the Cultivation of Sciences at Beaubazaar Street in Kolkata by generous public contributions. And it is this place that Professor C.V. Raman did his Nobel Prize winning research. And then we had a galaxy of outstanding scientists from Jagadish Chandra Bose, Prafulla Chandra Ray, Satyendranath Bose, Meghnad Saha, Prashant Mahalanobis, and Vikram Sarabhai, Homi Bhabha, and many, many others. And talking just about Professor Meghnad Saha, you know, he wrote the 2 papers in 1920, which were revolutionary, for which he should have got the Nobel Prize. And it is said that after Saha provided equations to describe thermal ionization, astronomers could determine precise temperatures of stars and the abundance of elements inside them. Thanks to Saha, humankind understood what stars were fiery balls of hydrogen for the very first time. And this is to quote from an article which has appeared recently. So in the December 29 issue of Allahabad University magazine, Professor Saha, then head of the physics department at Allahabad University, wrote an article for plea for an Academy of Sciences. And eventually the Academy was established on 4th December 1930. And in about 8 years' time, we should have grand celebration of our Academy. And I hope I live to see that. And Professor Saha was, of course, the founder president of our academy. And he said, but the main function of the academy should be towards cultural improvement by contribution to human knowledge. And we had great presidents of our academy. And this is a photograph of Professor Meghnad Saha during the Silver Jubilee session. And as you know, Professor Meghnad Saha wrote the first book on general theory of relativity, wrote an excellent book on heat, established the Institute of Nuclear Physics, and then Jadavpur campus of Indian Association for Cultivation Sciences, etc., etc., etc. So our educational institutions, R&D laboratories, and our academies have made great contributions to the growth of science and technology in India during the past 75 years. We have a flourishing nuclear energy program in India because of people like Homi Bhabha and Raja Ramanna. We have a flourishing space program because of people like Vikram Sarabhai, Satish Dhawan, Abdul Kalam. And we had the Green Revolution because of Professor Swaminathan, who was past president of our academy, and the White Revolution, and our current lead in the solar energy revolution, and then internet revolution that we have. And then we have India is the world's largest producer of vaccines. This is a phenomenal contribution. So, but we still have slavery, still have poverty, still we have 30% of our people living below the poverty line, and we still have corruption and these things. So the solution for future is through education, science and technology, ethics, and being less arrogant. So although our educational institutions, R&D laboratories, and our academies have made tremendous contributions during the past 75 years to the growth of science and technology in India, but we have to do more. So with that note, I welcome you all again and thank you for your attention. Thank you, Anirban.
Many thanks, sir.
Thank you, Professor Ghatak, for encouraging talks and in a brief time taking us through the history of the academy as well as the history of the freedom struggle. So it's time to move for the next talk by Dr. Monju Sharma, who was a former secretary of DBT, and she is at present Distinguished Women Scientist Chair, and she is also past president of NASI, and her energy and enthusiasm lead to today's program. So without elaborating on this, I will move to the talk of Professor Monju Sharma, and I request Professor Monju Sharma to say a few words about
Thank you, Professor.
Atmanirbhar Bharat and journey towards self-reliance.
Thank you, Dr. Anirban Pathak. First of all, very sincere thanks to you for organizing this event at a very short notice. So the Academy is really grateful to you for that. Honorable Professor Ghatak, Professor Akhilesh Tyagi, the past president, other distinguished scientists who have assembled here, the fellows of the Academy, and of course, above all, my very dear students. Let me start with a very exciting words of our first Prime Minister. He said, at the stroke of the midnight hour, when the world sleeps, India will awake to life and freedom. All of us are so familiar with these words of Nehruji. In 1947, we got the independence and from the British rule. And since then, we have been celebrating 15th August as the Independence Day. All the children are always excited in school children to say and sing Vijayi Vishwa Tiranga Pyara. So this would be here today all over the country, from the students, from the scientists, from the laboratories, from all over the country. Today we are celebrating the 75th anniversary of our independence, Azadi Ka Amrit Mahotsav. And our mind goes back to the words of Rashtrapita Param Pujya Mahatma Gandhi ji, who was the main architect of our freedom. He said on one of the Independence Days, freedom is never dear at any price. It is the breath of life. What would a man not pay for living? Happy Independence Day to all my people. These were the words of Mahatma, who, of course, you know, didn't live too long to really build this India what he wanted to do. I am very happy that NASI, the oldest of the science academies, as Professor Ghatak has said, has decided to have this event, online event particularly, so that we can all give some sort of a message to our, especially to our students and to the young people. Before I speak about Atmanirbhar Bharat, I want to tell you that governments throughout this period, 75 years, and I don't want to name all the prime ministers you know, have been supporting and making some efforts or the other towards self-reliant India, towards Atmanirbhar Bharat, particularly through science and technology. I recall the words of late Prime Minister Shri Atal Bihari Vajpayee ji. And what did he say? This very beginning when he had taken over, I have a vision of India free of hunger, fear, and illiteracy. Professor Ghatak has already said this. Education is one of the highest priorities of the country. Again, Atalji said, I dream of India that is prosperous, strong, and caring. An India that regains a place of honor in the country, in the committee of great nations. And some of these dreams, which we are trying to translate through science and technology, especially hunger, illiteracy, etc., they have become very, very important and an integral part of the overall socio-economic development of the country. Two of our greatest enemies are malnutrition and illiteracy. Both are troubling us at all levels, all the strata of the society. So many of the scientific institutions, academic institutions are working towards it so that we can to some extent combat malnutrition and eradicate illiteracy. The new education policy, all of you know, has all the essential components for this. I'm again very happy to inform you, my dear students, that NASI has made tremendous efforts towards science and technology interventions for science communication, popularization of science, awareness building, etc., etc. The latest example is the message through our academy, which has gone to people during COVID-19 pandemic. A large number of webinars on Jagrukta Abhiyan and appropriate behavior, COVID behavior, awareness about prevention and control of coronavirus through electronic and printed media. They have been organized all over the country, especially with the help of our local chapters, which is a very, very encouraging step that all over the country, these chapters are distributed and they are also taking keen interest to inform their students or the scientists or the villagers through video and films and cartoons, message about the COVID-19 pandemic and how to prevent it. Even control. The three aspects which have been focused in all these Jagrukta Abhiyan webinars are wearing masks, clean hands and sanitation, and social distancing. Testing, tracing, and treatment. So these have been conveyed by NASI's webinars all over the country. And not that NASI is only making the effort, there are several institutions, several programs of the health ministries of the state government, central government, Indian Council of Medical Research, etc., etc. But what I want to emphasize that academy has played a pivotal role in this. If really you look at all these, when we go for testing, tracing, we are using indigenous technologies. The diagnostic kits have been prepared in India. Of course, you know, the vaccine was developed in India. All these. So basically, we can say that these are all steps towards a self-reliant India. And S&T interventions so far in moving towards Atmanirbhar Bharat have been globally recognized. What India is doing has been globally recognized, and there are some very good examples. For example, we are totally self-reliant in the area of atomic energy. And as Professor Ghatak said, thanks to Dr. Bhava. Then we come to space technology. Again, to a great extent self-reliant, whether it is a rocket launch or satellite launch or Chandrayaan mission or Mangalyaan mission. Our space scientists have immensely contributed towards this Atmanirbhar Bharat. I come to a field which is relatively new, and that is biotechnology, which was supported fully and given a lot of encouragement by our previous Prime Minister, Shri Atalji. And today we are self-reliant in vaccines, diagnostics, many drugs, bioproducts, bioenergy, and we are moving now, taking a holistic view towards bioenergy. This is also a part of Atmanirbhar Bharat. Once India will totally focus on bioenergy, especially in our villages, things will improve drastically all over the country. Then HRD in biotechnology, especially bioprocess engineering in agriculture, biomedical research, ecological aspects, and in many universities, 75 universities, we have this human resource development program. The facilities like genome sequencing, DNA isolation, biocomputing, bioinformatics have all been set up again all over the country. And many clusters of academic institutions, synergy between science institutions, industry, PPP, the public-private partnership. All these have taken place during this year. And there are very special programs which all the science departments, I'm particularly talking of the science departments, all the science departments, the academies, National Academy of Sciences in particular, has organized for this Atmanirbhar Bharat, as well as part of the 75th year of our independence. NASI has played a very important role in this, and Neeraj will tell you many programs which we had throughout the year, and this is the last concluding program. A very major initiative of NASI and in the country has been the Entrepreneurship Development Program. And when I talk of Entrepreneurship Development Program, it is science and technology intervention in the entrepreneurship development. And there are more than 7 or 8 online events which have been organized by NASI, with also again with the help of local chapters. EDP, as I say, Entrepreneurship Development Program, is an integral part of Atmanirbhar Bharat. In fact, Atmanirbhar Bharat, the way we want to move in, these are different steps, and EDP certainly is one of the most crucial ones. Startups, again, is a very challenging initiative of the government. Requires innovations, translational research, product development, safety, marketing, and finally, to reach every strata of the society. In this, Honorable Prime Minister has a very important scheme, financial inclusion, which has played a very important role, including the MSMEs. More than 70,000 startups in the country are working today. They are focusing also on the employment generation, which has become an integral part of the activities of these startups. In EDP, as I said, science and technology is a critical element, and NASI webinars convey the message through the expert lectures, and especially the message goes to the students. The recent one which we had in Dehradun, large number of students, about 1,000 students were there, and they were so excited. At the end of the seminar, at least half a dozen students came and said, please guide us. In fact, Dr. Ram Gopal Rao was there, the director, former director IIT, and they said, please guide us. How do we go for the startups? And how do we go for entrepreneurship development, especially for employment generation in a state like Uttarakhand? The important contribution of these startups and the EDP program, EDP has been setting up a special ecosystem, the entrepreneurship development ecosystem and the startup ecosystem. And these platforms are actually really working. They have been established for a self-reliant India. That is the best part of it, that we don't have to go anywhere. We have different platforms in the country, different ecosystems where we can look for self-reliant India, efforts to move towards self-reliant India. One of the example of public-private partnership, which I must give being a biotechnologist, is the rollout of the indigenous vaccines during the pandemic. All of you are aware, so I won't repeat it. The Covaxin, which was developed in India, and the Covishield, which was produced. And Professor Ghatak has already said that India is the largest producer of vaccines in the world. And during the pandemic also, we have supplied vaccines to many countries. And we have today 200 crores people vaccinated in the country. That's a great achievement for India, and the world has recognized it. WHO has recognized that India has done a remarkable job during this pandemic. And who's played a pivotal role in this? I'm sure all of us will be very proud to know that it is the scientists, technologists, the biomedical experts. If a scientist wouldn't have isolated the virus at an IV, where was the Covaxin? So it is really, we should feel a very proud moment when we say that we have self-sufficient during this pandemic in supplying the vaccines, and so many people have been vaccinated. At least to some extent, we can prevent this infection of coronavirus. Repeatedly, again and again, the Prime Minister has been repeating this, that this is our Honorable Prime Minister, Narendra Modi ji has been repeating this and enthusing the younger people, the scientists and technologists in particular, to work towards this. He says, and he's very confident, Atmanirbhar Bharat will be a force multiplier for the global economy. These are the words of our Prime Minister. I'm at the same time, as all of you know, and many of you are also, I'm also very confident that the efforts of our scientists, the academies, the scientific infrastructure which we have created in research institutions, national laboratories, will make a sustained efforts towards an environmentally sound, sustainable development of our country. That is the confidence we should have. And I want all of you, I see many of the younger people, Professor Alok Dhawan and many of the Shubhra Chakravarti, these are all very young people. And I want all of them to feel that yes, through our academic institutions, through our infrastructure, through our trained scientists, we are moving towards that. And wherever possible, we should try and provide the training also. This part also has been repeatedly emphasized by our Prime Minister. So friends, all of us must work towards self-reliant India. And again, I want to conclude with a very wonderful song which many of you would know. I'll just say one line. दे दी हमें आजाद बिना खड़ग बिना ढाल, साबरमती के संत तूने कर दिया कमाल. Thank you and Jai Hind.
Thank you, madam.
Thank you, ma'am, for beautifully telling us a large amount of stuff about different programs, possibilities, and future scopes, dreams in very short and precise talk. So now we'll move to our next talk by Professor Paramjit Khurana, who is a professor in the Department of Plant Molecular Biology, University of Delhi, and a renowned biologist. And the talk will be on women in science. And before I over it to Professor Khurana, I would like to mention that NASI Delhi chapter is organizing throughout the year a series of lectures on the eve of Azadi Ka Amrit Mahotsav, and the series is called Women in Science Lecture Series. And the next lecture of that series is planned on 24th August, and it will continue till October. So we have already organized several lectures by prominent women scientists, and that's indicate that post-independence there is a successful science done by several women scientists, but a dedicated talk on the success of women scientists in independent India will be given by Professor Khurana, and I'm over to Professor Khurana. Please.
Thank you very much, Nirvan, for this kind invitation and for organizing this program at such a short notice. A very warm welcome and good afternoon to Professor Ghatak, Dr. Manju Sharma, Professor Tyagi, other dignitaries and other scientists and participants who are there in this program. The topic which has been given to me is the role of women in science. I think the biggest challenge for women in science has been in confronting inequalities. Very difficult to make a distinction between pre and post partition, but I'll try my level best to go about it. So I think an equal world is very important for women in this, and there are lots of international efforts done by different countries at different platforms to make it an enabled world for the women who work in the field of science. Even if you look at the Sustainable Development Goals, the goal number 5 talks of gender equality. I think this is fundamental to the progress of women. It not only empowers women and girls, it ends discrimination, it ends violence, it ensures women's participation, recognizes their work, recognizes their leadership in decision-making, and many other things as well. In fact, I look at the progress of women as co-evolving with that of civilization. Why do I say that? I feel that agriculture has been the backbone of civilization. Since the way when agriculture was started, a man evolved from a wanderer to a gatherer. And we have seen agriculture co-evolving with the civilization of mankind. Of course, there are different theories on that. I think they're highly intertwined, and I'm very happy that we have two excellent speakers speaking on these aspects subsequently, although whatever short time it may be. So agriculture, while agriculture is the backbone for food security, when we combine it with gender equality, I think this is where the real essence comes in for women empowerment. Because in fact, if you look at the statistics also, nearly 60% of the undernourished population is of the women and the girls category. But why I bring in this slide is particularly to indicate that although women are a major participant in the agricultural enterprise, there are lots of agricultural gender gaps related with gender. There are gender inequalities here. They have lesser access to rural resources, to the services, to the market and other things here. And even women's role general has been very undervalued in the agriculture enterprise here. That is why I feel that there is need for gender neutral policies. And we also do not have gender specific data available as to what is the contribution of the female participants, of the women folk in the agriculture enterprise here. But I'm very happy to note that, yes, people are slowly changing, this perspective is being changed, and people have started talking of women in agriculture and celebrating their role. And I was shocked actually to see the statistics that in India, nearly 78% of the women they are employed in the agriculture sector. I think that is a tremendously very high figure. And of the farm work which is done in the fields, nearly 70% is undertaken by women. And of this, if you look at the rural women, nearly 50% of the agricultural labor is of the rural women population here. And the world produce, irrespective of our boundaries, of our geographical distributions, 60% of the food is grown on this planet is grown by women. I think that speaks volumes as to the role of women and agriculture in our civilization. That is why there is always need to empower women in agriculture as well. And I'm very glad that India has made some very outstanding, with the future vision, certain institutes have been created. And one such institute is the ICR Institute, which focuses specifically on the role of women in agriculture. It's situated in Bhubaneswar, of those of you who don't know about it. And it has been categorized and it has won the best women empowerment in Asia as well. And NASI has collaborated with ICR in instituting certain awards also for innovation and research on farm implements, where these are certain awards which are highly prized, highly appreciated, but the innovation should be on the focus on the innovation is to reduce the drudgery of the farm women and the development of farm implements which are more women friendly. I think that is one thing which NASI has done, which no other people have done that. And it is only thanks to the vision of our former president, especially Dr. Manju Sharma, to bring out this aspect and to collaborate with ICR to get this thing effected out. We talk of many things, but their implementation is often staggered and delayed. But this is one thing which is very well done, and NASI should take pride, I think, in doing this. And also, it encourages a lot of researchers and innovators to develop the farm implements, whether it is the entrepreneur program, the other programs, and so forth. In fact, women have played a central role, not only in agriculture, but also in healthcare worldwide, internationally also. And healthcare, it could be in different aspects of healthcare. It is not only the doctors, service managers, if you look at it, the administrators and others who manage the healthcare system also, you'd be again surprised to see 70% of them, the roles are performed by women. So I think that's an outstanding amount and an outstanding contribution, unsaid of, unsung, which is there here. And in fact, even at the smaller level, at the family level also, nearly 80% of the health-related decisions, they say, are taken by women. And of course, they make up the whole here. And they are the major caregivers to others who are in need of this healthcare. So women play very deep-rooted roles in the healthcare sector as well. I also want to point out one thing, that India, we are a very proud country. We are celebrating our 75 years of our independence. We have also been very fortunate that our constitution was very far-sighted. It is inherent there are two wonderful concepts inherent in our constitution. Number one is, of course, the freedom of speech, which is the backbone of our democracy. And the second is, I think, that a nation with a scientific temper. I think we're losing sight of this, and we need to highlight this aspect as well, that the Constitution laid down in black and white that we should be a nation of scientific temper. Many people don't understand what do you mean by scientific temper. It is actually a way of life, a process of thinking, a method of acting and associating with your fellows. We are slowly drifting away from this particular aspect also. And that is where I think in fact, many people say with the IT, India is more known for its IT contributions internationally. But they say that the infrastructure of science and technology in India, if they say that that is the hardware, it is the scientific temper which is equivalent to the software. So you cannot function with, do anything with the hardware unless you have the software. And that's where our attitudes towards different aspects should need to be scientifically oriented, I would say. And the latest science and technology innovation policy also lays lots of stress on spreading scientific temper amongst different sections of the society. And it is here that NASI is again contributing in a very big way. If you look at the women researchers internationally, these are some of the figures which are okay and not very okay. There is always scope for improvement. But what is important is to see how do we fare as compared to the other countries. Look at Europe. Nearly 50% of the scientific research is done by females. In India, it is about 20% or so, keeping into fact that this is an older statistics here. So we have tremendous scope for improvement at this aspect. And they always say that women in science, women in science. I think science is gender neutral. We do not classify science based on science done by women or done by men. But yes, the women who work in science or the women scientists who are there, they have to struggle a little bit more. I know there'll be repercussions on this as this statement of mine, but they have to compete. They have to put in more efforts as compared to their male colleagues to come to the same level. That is true, and lots of people will agree with me on that also, although they may be similarly classified and qualified and otherwise also. So it's been a tough fight for women to succeed in science everywhere, not only in India, but otherwise also. But then nothing is without problems. But fortunately, let's look at the positive sides also. The face of Indian science is changing. And what is that? It is this, you know, I mean, it's such a lovely picture. It is self-explanatory, you know. The women working at ISRO were basically credited with the success of the Mars orbiter. I think this is a very, very, very motivational picture, and it speaks volumes of the role of women in science. And of course, Tessie, we call her now the missile women. And she also, yeah, I indicated here, she is the one who's been said that she's broken all glass ceilings and reached where she has done. Like Madam also mentioned, we've done exceedingly well in healthcare. We've done very good in the space sciences and others. But when we look at sciences and include, or we go broader and say STEM, there have been lots of documentary evidence. We have lots and lots of role models who have done exceedingly well. We've had an incredible journey, each and every one of them, you know, who've done this. And now there's been the Confederation of Indian Industries has also taken out some others. They give you the perspective of what women have faced and how they have reached to the level there. They make for some very good reading, interesting reading, and they're actually very motivational aspects for the younger folks, those of you who read. I look at this picture and I say that these are our poster girls of women in science of India, you know, at the international level. Of course, she is there, Gagandeep Kang is there, and even Soumya Swaminathan. Imagine what laurels and what stature they have brought to Indian science, Indian women doing science at the international level. I think it's a beautiful picture, and I call them our poster girls of women in science here. So the Indian science is changing in a big way. There has been better gender equality after 75 years of our independence. Earlier, it was just on paper, but now we can see it getting translated. So we are not taking baby steps anymore, but you can see the reality. Now you can see the translation effect which is coming in because of the gender equality in science also. People's perspective is changing. The education policy has played a very major role in this, I would say. The recent slogan of Beti Padhao, not Bachao, but I would say Beti Padhao itself speaks volumes in itself, because education is the backbone of everything, I would say, in our country. There have been certain practical things also. When we were younger, I would say, we had maternity leaves was only till 3 months or so. And at that time also internationally, I remember being part of some delegation, people were shocked that India gives you 3 months of maternity leave. Because in other countries, they don't get any maternity leave. They have to save their leave for such things here. So India has done pretty well. And now they've increased it to 6 months, and then it has now come up to 9 months also. So these are practices which are leading to better representation of women in science. These are proactive practices that whenever there is equality, try to promote women, and people are now doing that also. I would not say a reservation part, but otherwise, yes. All these practices lead to a more enabling environment for women also to fight equally. And in fact, the best thing which I say is, at least people are now started recognizing that science research also could be a career in itself. Earlier, it was thought of only teaching or doctorate or engineering and other things. Now, slowly, the general population is accepting that research is also a very good career option, which is presented. And I would say it is all because of these effective government policies, which have come up not today, but over a period of time, which now you can see that the results are coming up into practice. What is very important and what NASI is doing in a very big way is taking science to the society. I think like Dr. Ghatak said that our founding president also wanted that science should go to the society. And with some very good leaderships which are available in NASI, we are seeing the implementation of science, taking science to the society, and society also at different levels of the society. And many of the NASI programs are tailored to cater to a specific category, a different type of society. I think that is more satisfying and very encouraging, I would say. Of course, backbone is education. I wish there is more on education also being done here. That is like my wishful thinking, that we need to have more education promotive effects also. This is one diagram which I do want to, even till today, it hurts me to see what is, if you compare the world expenditure on research and development in the countries, small country like Finland, Denmark, Singapore, they spent enormous amounts on R&D practices per head capita. China and India are now nearly equal in population. China also spends about double the amount what India spends. You know, what is very sad to see that India spends very little on this. And that is where I wish everyone who has an opportunity to convince the higher up authorities to allocate more to research and development in the country. And if you see I mean, I don't want to get into the figures of it, but what do we spend of whatever share we get of that little, nearly 32% goes into defense, DRDO. 19% goes to Department of Space. Only 11% to 12% goes to ICR. Imagine, ICR is what feeds the entire population, and they get such little of it. Look at Department of Atomic Energy, 10%. CSIR, huge number of institutions, 9.5 barely. Department of Biotechnology, 3.7. ICMR, 3, the lowest, where health should have been one of the major concerns and major investment areas. Why can't we have it equivalent? I think defense and should be on equal footing here. I think these are the figures where we need more input. We need to convince the authorities to give us more, because this is what will lead us further. We do celebrate International Women's Day, International Day of Women and Child. I say that these are days which should not be celebrated only once in a year. All 365 days in a year are Women's Day, days for this and this. I think what we need to celebrate so that we can focus upon is the education days. I think there is very little focus onto that. Once we educate it, only then we will be able to realize our dreams and see equality at the ratio which we would want it to be here. Because I find that it is the lack of education which leads to inequality. And that is why education is a most important tool for empowerment of women to fight for their rights, irrespective of what area you're working on, what you're doing and what not you're doing. This should be a fundamental right, and we should work for that more. It is like roti, kapra and makan. We should include education also with that, I strongly feel. NASI's initiatives, wonderful of them, beautiful. We've had lots of workshops at different places. Volumes have been written, awards have been instituted, not only for that, but also for research. See, Young Scientist Awards have been given with good publications which come up in a big way. books and volumes have been written at different times of period by different people on different aspects here. Time is limited, so I will not go into that here. But yes, in the end, I would say nothing would have been possible had some of these trailblazers not done their work here. So I would say I would take this opportunity to thank all the earlier women and scientists, the real trailblazers. Without their work and effort, we would not have been able to do anything what we have been able to do here. So in a nutshell, I would say I'll say thank you for your attention. And my views are very personal. I may not have been totally correct at many times, but I feel there is a lot of scope for improvement. We've done well. You've done well, but we could have done even better. Thank you very much.
Thank you, Professor Khurana, for excellent talk. And as you rightly said, that agriculture is in the backbone of civilization. So now it's time to move for 2 consecutive talks on agriculture. And I do feel that there are many discussions on what is the main contribution of Indian scientists post-independent. The biggest contribution is probably from the agriculture scientists, because the population has increased so much and the land has been reduced, farming land, and still there is no scarcity of the food. So we'll listen more about the development of agriculture in independent India from Professor Akhilesh Tyagi, who was past president of the NASI and a renowned biologist. So over to Professor Tyagi.
Thank you, Professor Anirban, for giving me the opportunity to talk on this occasion. Honorable Dr. Manju Sharma, Professor Ghatak, dear fellow colleagues and officers of the academy. Today, we all have listened our Prime Minister Modi ji in the morning, and he enunciated 3 principles. The one is Atmanirbhar Bharat, Nari Samman, और जय अनुसंधान. ये 3 मैंने नोट किए स्पेशली, and I see that Atmanirbhar Bharat and Nari Samman has already been talked about by Honorable Dr. Manju Sharma and Dr. Paramjit Khurana. So obviously, I will restrict myself to Jai Anusandhan in the area of agriculture. But agriculture is an area which is embodiment of all 3 of these. That is Atmanirbhar Bharat, Nari Samman, and Jai Anusandhan. Now, when we think about this, we can begin by remembering those who have contributed tremendously to the growth of agriculture and plant science in last 75 years. And we are immediately reminded the names of Dr. B.P. Paul, Dr. Swaminathan, Dr. Birbal Sahani, Dr. P. Maheshwari, and Dr. Janki Amal. Of course, there are several others without whose contribution it has not been possible to make India self-sufficient in the food area. When we think of these contributions and contributions of agriculture scientists and the farmers of India, we are also reminded immediately of Green Revolution that started in India in 1960 and in next 30 years contributed tremendously to the increase in the food production. We know today that continuation of Green Revolution in the form of Evergreen Revolution has resulted in the production of food grain to the tune of 320 million tons, which is 6 times more than what we were producing in 1947. Also, we are producing vegetable and fruits about 330 million tons, which is 12 times the vegetable and fruits we were producing in 1947. This is a remarkable achievement, and this has allowed us to export 20 million tons of the food today, and also the reduction in poverty has been from 70% to 17% in these many years. This 17%, of course, reminds us that we have unfinished task in front of us, and we need to continue our efforts to overcome and remove hunger and malnutrition from the face of our country. Now, this work on Green Revolution and subsequent work has resulted in release of 6,000 varieties of the crops in India. And out of these 6,000 varieties, there is also a contribution of industry in the form of several hybrids and quality seed, which they have been able to provide. The continuation of Green Revolution resulted in our attention towards the millets, and we have been able to increase the production of the millets fourfold in the recent years, and therefore we are moving in a direction to achieve self-sufficiency in real terms when India will be free of hunger and malnutrition. As we moved, there were new technologies which were developed, and Dr. Manju Sharma mentioned about biotechnology. And one of the early steps was taken in the form of micropropagation. Micropropagation of horticultural crops like banana, sugarcane, pomegranate, and so on and so forth. This business today is about 500 crores per annum, and large number of micropropagated crops are being cultivated all over India, and we consider that we have another 50% potential as of today, and this potential can be increased further. Another anusandhan which happened in the area of agriculture sciences is the GM crop. A single GM crop, that is BT cotton, has provided betterment of millions of farmers who are cultivating cotton and adapted it up to 90% of the total level. And this provided India a bioeconomy of $10 billion. So we can imagine if other crops, GM crops in pipeline are released, then what will be the state of the bioeconomy of India? I should also mention that as we moved further, we entered the area of genomics. And it was because of encouragement and understanding of Dr. Manju Sharma that we were able to sequence the first genome participating in international program, and that was the rice genome. After that, several efforts have been made, and Madam will be happy that we have learned the tricks of the trade, and we have been able to sequence plants like tomato, chickpea, pigeon pea, wheat, jute, mango, neem, tulsi, mulberry. This clearly lists the plants which are of special importance for India. And when this technology came into existence, simultaneously came into existence the marker-assisted breeding. And you will be happy to know that today India has already released 55 varieties which have been developed on the basis of marker-assisted breeding, which in turn emerges from the genomics. We are now, friends, in the era of genome editing. And already Indian scientists are working in the laboratories to produce genome edited crops. One variety, that is MUT 1010, has already been genomically edited to produce drought tolerant varieties. And important thing is that government is also moving with the scientists, because the national guidelines for release of such kind of genome edited varieties have been released and should pave the way for fast release in comparison to GM crops. So this has been the development. Of course, with this kind of development, it is also time to think that what we have to do in the coming years. Of course, there would be a long list of such kind of activities, but I have tried to list only 5 of them. One of them, and that is the first, is the more from less. This is one in which we need to have more yield by giving lesser input so that we can have environmentally sustainable agriculture. The second point relates to climate change. This year itself, we have seen the erratic summer and also the erratic rain has caused tremendous loss to Indian agriculture. For the first time, we are challenged in terms of production, and therefore it is necessary that we have such crops which can face these climate changes. And you will be happy to know that already there is work in final stage on heat tolerant wheat and drought tolerant rice. So these are the possibilities which have come our way because of the use of the genomic science. The next one is the nutritious food. Of course, Dr. Shubhra Chakravarti will talk about it, But I should like to mention only one thing, that we have already released 71 biofortified varieties of different crops. 17 of them were recently released by Modi ji in a special program. These include our effort on the improvement of the protein content in chickpea, as has been done by scientists of NIPGR. Of course, I should also point out that provitamin rich banana is also available in India. Only thing is that when it will be made available for people after its evaluation. The fourth one is the importance that we have to give to Dharti and of course the Santan of Dharti, which I like to say the Dharti and Dharti Putra, that is the soil and the farmers. And why it is important? Because if soil deteriorates, then it is kind of a womb of the mother. We will not be able to get output from this if we are having a sterile soil. And therefore, it is necessary that we look into it, and recent development in the area of nano fertilizers and also in the area of soil cards are paving the way for providing due attention to this area. Of course, we need also to scientifically and at molecular level look at the root system, which has been neglected. Most of the times we have looked towards the output that is above the surface, but it is something below the surface that is providing the existence or supporting the existence what we see above the surface. And the last one, of course, is the empowerment of the farmers. And in this area, of course, the science is adding a lot. We have seen recent developments in the digitalization of agriculture, when farmers can be connected with the knowledge of environment and also the knowledge of the market together through simple apps. And also, ultimately, I would like to say that all these things should ultimately move towards improving the purchasing power of the people of India, and also improvement in their income. That is the task for set for the government. But we know that as scientists, as Anusandhan Karta, we can contribute to this tremendously. And I appeal to all of this, all of the scientists to look into this and work and शपथ लें आज कि हम इस दिशा में सच्चाई के साथ कार्य करेंगे. धन्यवाद.
Thank you, Professor Tyagi, and for wonderful talk and making a platform for next talk, because this talk was, and actually all the talk so far was about what we have done in 75 years of independence. And now we'll move to 2 talks where we'll talk about what we plan in next 25 years or even in the later future. So the first talk is by Professor Shubhra Chakraborty, Director NIPGR, and she will talk about priorities of plant research in next 25 years. And the beginning of the talk is already initiated in the previous talk. So the discussion on agriculture will continue, and I request Professor Shubhra Chakraborty to deliver her talk.
Thank you, Dr. Pathak, for giving this opportunity, and a very good, happy Independence Day to all of us, as well as people who are with us offline and online today on this 76th day of the independence of our country. So respected Madam, respected Professor Ghatak, respected Professor Tyagi, Professor Khurana, many others, my friends and colleagues, and maybe some young students who possibly are with us. So I thought to choose a topic on nourishing 1.62 billion sustainably, and what would be the priority for our plant research. Since I'm speaking from a platform of National Institute of Plant Genome Research, I would restrict what should be the priority of plant research in next 25 years. Today we are celebrating, as I said, 75th Independence Day. And you know that this year is also, we are celebrating 125th birth anniversary for Professor Janaki Ammal, who was actually the first Indian woman to be awarded a PhD in the subject botany, and that means it's a direct relevance to the plant research. So, today, as many of us have heard our Honorable Prime Minister, that we are a nation of 1.4 billion population. So the question comes when we are enthused and thrilled of thinking that how India could move forward to become Atmanirbhar Bharat, and we look forward for next 25 years. That means when India becomes celebrate 100th Independence Day in the year 2047. So what happens then? So if we look into the UN projection, that time in 2047, we would be the largest nation on the earth in terms of the population, surpassing even China, and with more than 1.6 billion people, of which 60% of them would live in town, and still they would be below global average of 2/3 actually in 2050. So in that situation, as we all heard Professor Tyagi, and we know that from the independence, from a ship to mouth situation, we came today where we are self-sufficient in our food production. And today, India is the largest producer of spice, of cotton, of pulse. We are the second largest producer of rice, wheat, which are the two staple crops for us, as well as fruit and vegetable. And it is also the largest, we are also the largest exporter of rice and spice today. And for our basmati, that India actually get lot of return when we think about the production of basmati rice that has come in play in this last 75 years of research and contribution from the agricultural scientists. And that's a huge return that India gets from the agriculture. So if we look then, I was thinking while Anirban asked me to give something, and I saw Professor Tyagi is talking, so therefore I didn't want to go into that, but maybe a little bit overlap would be there with him. But I thought, what could be the challenges in this next 25 years that we need to now join hand together, work together to achieve and take our nation in the food sector? I think we have four-way challenge. One is nourishing more than 1.64 billion, and at that time world would have 10 billion people by 2050. So nourishing this huge population is the first challenge, and that should be by reducing a carbon footprint. And therefore this is a very important issue, that how do we reduce a carbon footprint, which basically is also an offshoot of our food system, because our food system produces this carbon footprint. The type of food that we intake comes from animal food, actually releases maximum carbon footprint, and therefore the whole world is moving towards a vegetarian diet, many of the cases. But then we all know rice straw burning, many others, which also increases the carbon footprint. The challenge, therefore, is how do we make nutritious food feed our growing population by reducing the carbon footprint. Second is, as Professor Tyagi also mentioned, that we need to think about to make more resilient to crops, more resilient to climate change. And we all are seeing that what is happening. And also if we see the IPCC projection, that not only the flood and the drought, but the major concern would be possibly increasing heat, which is more than 2.5% as per the IPCC 2018 data. So therefore this climate change, and also we see when we increase kind of heat in the world scenario, even this year when we have seen in the UK has seen first time so much of temperature rise that it was never there in the history of the UK. Even in the global warming affected the US, other parts of the world, India saw more than 49-degree temperature in the summer. So this heat would be a very, very challenging concern. And also when we have more heat, that also would impact our, the ecosystem, where we might have more of the pathogens, which are phytopathogens which infect the crops. And therefore, this climate change, to make a more resilient crop system with this change in climate, will be a second challenge. Third would be, how do we actually eliminate the damage in our biodiversity? It has two-way impact. One is that, you know, even in India, if I think there are total 34 biodiversity hotspot, as we all know in the world, India has 4 of them. And if we look into that, what kind of crop we actually use for our food when we talk about plant-based diet, then it's only 12 crops that regularly been used all throughout the world. India is no exception. However, we have huge biodiversity. So then can we use this biodiversity also to induct into our food system? That would be, and therefore we need to see that there is no more loss in our biodiversity and we protect our biodiversity. The fourth one would be basically the resource depletion and pollution that is resulting from the agricultural production as well. As I mentioned about one example, which is the burning of straw. So therefore, how do we now, the next question comes, if we think that these are the 4 major, if I could point out 4 major points to take care, and then we need to see how plant science and what would be, as a plant scientist or a student who is studying plant science, how do we actually cope up with these challenges? Now, food security is the first one. Now, the food security, if we see, we know that India is the country who has the highest number of people who are malnourished. I'm not going to read today about the numbers and figures. Many of us know and we know about it. But then we are going to have more of malnourished children in near future as well. At one side, we have a malnourishment, but at the other side, because of the food habit that we have, we also have another way which we are seeing is an imbalance in access to food. And while million goes hungry, we also see that there are many people, almost more than 2 billion worldwide, are overweight. And these are where we need to think about our food habit. We need to change our food intake and how do we take care this double-sworded problem. That is the most important thing that we need to address. And if we see by FAO data, and you know that trend is a challenge will intensify, the demand for food also, and substantially by 2050, definitely FAO estimated almost 50%. Second is that food for net zero. And that's very, very important that we need to take care that how do we reduce the carbon footprint, but increase the food production, where the science and the technology would come very, very important to play a role in having this kind of situation. Third is the food resilience. As I said, crop yield would be very, very highly affected by flood, heat, drought, climate change, as well as pathogen infestation. So this is another area. And I have already talked to you about biodiversity. Just to share with you, we have almost 25,000 species which have been identified as threatened with extinction, and around 13,000 species are threatened by agricultural land cleaning and degradation. That's why I'm saying when we talk about plant research, plant biology, which is directly linked to the agriculture, this agriculture clearing and degradation also amount to the threatening of our biodiversity. So it's two-way around, and almost 3,000 by hunting and fishing that we lose our biodiversity in our food system. So then the question comes, what more do we need to know now? Now, how science can support this low carbon, climate resilient and nutritious food system that is required to feed our growing population in next 25 years. I would say it's only 2 points, and that is, how do we make a sustainable food production? That means we produce more food with reduced carbon intensity and a lower environment footprint. And the second is, how do we use our sustainable food technologies, and how do we come up with developing newer technologies which could improve both the yield and the resilience through our breeding, which could be molecular breeding, which could be transgenic, which could be gene editing, and many genetic approaches, and with newer and newer innovations. So if I think that, Professor Tyagi also mentioned today, Honorable Prime Minister, while speaking from the Red Fort, mentioned about Jai Jawan, Jai Kisan, and also he talked about our earlier another Prime Minister, Honorable Atalji, who talked about Jai Vigyan, and today the Prime Minister added Jai Anusandhan. So if we use this Jai Vigyan and Jai Anusandhan, where we are doing a plant research, I'm sure that we would be in a situation that we could mitigate all these problems with our younger generations and come up with the support of scientific innovation that can support the sustainable intensification in many, many ways. And it can create new climate resilient varieties of crops, which can have higher yield, require less fertilizer, less water, and less pesticide. And then I would just take up one example where just 3 weeks back, a paper came in Science Journal, where a group of Chinese, scientists of 13, they found out a group in China from the CAS, 13 genes were turned on by only single one gene, which is a transcription factor. And that is a transcription factor already the rice plant had in it. So it's its own copy. If you now express it, that showed that it can give five of the genes led to a fourfold increase in greater boost in nitrogen uptake, and then that led to actually also 13 genes which boost the photosynthesis. And therefore, by engineering one single gene, which is a transcription factor, they found in a Chinese cultivar, which is Nippon bear, 40% yield increase. And this is, in this century, I think in plant research is the most important, I would say, translation that has come into play, because genes came, we knew genes before. And then this also had a good nutrition, and which could have been found out by isotopic driven technology, and that said about nitrogen input. So now let me come to a end of my saying that how do we do all these things? I would say that in the after the first 25 years of our independence, we actually did a lot of molecular biology. We understood what is gene. Then Professor Tyagi mentioned next 25 years, genomics has taken place. And now lots of data. So first and foremost thing, how do we utilize this data? So therefore, creation of database, which is there in terabytes. So we need to train our younger generation, and the HRD would be very important, where we train our younger colleagues, younger students, how do we use this data biology to make sense of the trillions and billions and petabyte data that is there everywhere in the database. That's a very, very important issue that I would like to flag. Not only that, how do we use the artificial intelligence and the ML in agriculture, in plant biology research? One example Professor Tyagi also mentioned, and we know that what had come into that using this, threat in Rajasthan, where the government used a e-locust tab and e-locust M to control a kind of a locust attack that had already came in play. Already farmers would be knowing about digital farming, but how do we now use this digital AI and ML in the lab to make sense out of the data? That is where the research need to also focus, because we have enough data by now with all this omic technology that has come. And the second is that the area would be actually, we can't increase the land area. Then how do we use the farming system where we could possibly make more food using less area? So vertical farming, as well as, speed breeding and high throughput phenotyping. Let me say one example that Department of Biotechnology has taken in last year, that India has a lot of biodiversity. India has huge germplasm which are there in NBPGR, and they have been taken out of 8 crops, including rice and wheat and chickpea and many millet and many others, where this in next 4 years, it would be a huge potential that we would be generating. I don't think any other country in the world has this kind of an ambitious project, and we are all ambitious and we are all excited, and I'm very, very, positive about it, that when this goes, and there are in every crop more than 17, 18 institutions, including Agricultural Institute and the basic research labs are involved, where we are going to tap all the genes and we would be tagging them with different kind of traits, what I talked about, climate resilient crops. And this huge data would actually be the gold mine from where we could get our resource, and we could improve by using newer technology like genome editing, like speed breeding, and we make more food which are nutritious and climate resilient in next 25 years. And that is where I think that we are going ahead, and we would be able to do it. The last but not the least, we all are enthused as scientists and students and researchers. What we need is a support from our government. Our government supported us all 75 years post-independence, no doubt about it. That is why we are today here. However, the research budget, the one slide that Dr. Khurana showed, we need to keep in mind that GDP has to be invested in science and technology. We cannot compete with even our neighboring country, China. And why so? We need defense budget, but we need science and technology budget. That's one thing. Second thing, policy is a very important issue. We have seen what has happened to the transgenic research. We are entering to a era very enthusiastically for a genome edited technology. I hope that we will be able to reap the benefit of these technologies, and we won't go back to a negative way. And therefore, science budget and the scale at which the technologies to be implemented need to be seen positively. With that, thank you very much.
Thank you, Professor Chakrabarty, and for a wonderful talk and stating the directions in future. And with the same spirit, I'll continue, and my talk will be more about a personal dream. And I'm being a physicist. It will be more focused towards physical science and how the dreams come, how our and I just switch on the slideshow first. So I plan to talk the kind of concluding talk of dreams of a scientist after 75 years of independence. So in the last 5 small talks, mini talks, we have heard a lot about what happened in 75 years. Now I want to talk that means how more or less personally I dream that what can happen in near future, and when the kind of things which will happen, and I'll feel, or we as scientists will feel happy. But anything has a sequence. Nothing comes all on a sudden, means that it's not quantum leap. So all this thing started from, so I'll start from a pre-independent era, and just after independence, how the founder of the National Academy of Sciences, India, NASI, Professor Meghnad Shah dreamed it. So he dreamed of a heavy industry, and sometimes the great people had conflict of thoughts. So this thought of establishing heavy industry was conflicted with Gandhi's thought of making small scale things at the charkha and all such things. And Shah eventually found in his favor Netaji Subhash Chandra Bose, Nehru, and Rabindranath Tagore. So they were there, but so post-independent planning commission started, heavy industry started, and employment to a larger scale become possible, and we are seeing some good effect of that. Shah thought of river planning, and he started planning for flood and so to control flood, dam, and many such things. Damodar Valley Corporation started, but still there are so many flood because the modeling has been changed. Now we are making flood map, So we were part of an Indo-US project, and only for Kerala a flood map is prepared. So I expect that very soon there will be a flood map for the entire country, and many mathematicians or a computer scientist or a physicist will contribute to that and make the map as complicated as possible, in the sense that viscosity, local data of the fluid, the land conditions, how many plant has been reduced, where the ponds have been blocked. So everything should be included in the model, and we'll have a good flood plan. Calendar reform Shah tried, but which was not much successful. Nobody accepted the calendar, and we are still continuing with many of the old calendar. So these are some early thoughts which lead to the present thing, but I'll continue with what prompted me to think about what can happen in near future. So where we stand, resources are not optimized. We still have flood, invasion, hunger, and unemployment. The dream is to solve these issues via science. Now, when we talk about independence, freedom, our Gandhi, Shah, we often become emotional. But there are other occasions where also we become emotional. So in the lower part, in the middle, central part, there is a picture of my lab. We have just started a quantum cryptography lab. Very few such labs exist in India. But now, when I look, if you enter from this gate and go to my lab, there is only an optical bench which is prepared by Hallmark, a company based on Kochi. Not a single component, apart from these wooden boxes, are prepared in India. So why do we need even small component? After 75 years of independence, I still have to buy a lens from Newport or Thorlab. I cannot even prepare a small good quality mirror. So here is a cartoon. Which part of your component of your lab is made in India, and only optical bench. So in that context, the notion of making India is pretty good. But what is happening is, in the name of GTE, we are making it even difficult for procurement, and then we are buying the foreign stuff with Indian package. So that's not the notion. Means I dream that when not only the box will be Indian, what is inside the box will also be Indian. So we need to do science for society. And I mentioned that in context of Gandhi also, Gandhi and Shah had a conflict of the notion of need of kind of industry, small scale industry versus heavy industry. So Shah had a conflict of thought with one of our favorite hero for all physicists, Richard Feynman. Richard Feynman thought, the last quotation in the top, that the scientists normally don't involve in social problems. The reason being that we know we don't have any magic formula for solving social problems. Social problems are very much harder than scientific ones. So we solve what we can do. We solve hydrogen atom, we solve harmonic oscillator. Those are easy to solve. They have less number of parameters. But a social problem, even if you think to model a river, to model flood, there are multiple parameters, and solving such equations have become pretty difficult. And scientists often avoid such problems. So Shah was also that breed of scientist till 30. And then he wrote that scientists are often accused of living in an ivory tower and not troubling their mind about realities. Apart from my association with the political movement of juvenile years, I lived in that ivory tower till 1930. And then there was a change. So the change is reflected in the last quotation. If we desire to fight successfully the scourge of poverty, and one from which the 90% of our countrymen are suffering, now the percentage has been reduced, but it's not zero. So if we wish to remodel our society and renew the spring of our civilization and lay the foundation of a strong and progressive national life, we must use the knowledge of nature as given by the science. So this is in the backbone. And NASI is still continuing in that direction, organizing many science and society problems. But whenever we talk about independence, we normally talk about political independence. So it's not restricted to that. And often popular movies like Main Azad puts us or compels us to think about more thought-provoking questions, that what kind of independence is actually needed. We need to be independent and self-sufficient in food production, which has been discussed in the last two talks. Medicine production. So in vaccine is a success. We have become largest producer of vaccines, but the medicines has to be designed in our place so that the patent remains, the price can be controlled. And of course, we need a strong economy, and each of this is connected. So we wish to transform India from an importer to exporter. So as far as my personal field is concerned, quantum technology, there is a new mission called National Mission in Quantum Technology and Applications. And in the goal itself, we mentioned repeatedly that we miss the semiconductor bus, but we don't want to miss the quantum technology bus. We want that we become independent as far as quantum technology is concerned. We should not import things. We should be in such a footing that we can export quantum technologies when it's in reality. Now, Professor Ghatak in the beginning mentioned about Dr. Mahendra Lal Sharkar, who established Indian Association for the Cultivation of Sciences. So one of the reasons for establishing this was a realization. So Dr. Sharkar wrote in a place that he realized that even we become independent, unless I do well in science and technology, will not be able to keep the independence. And he mentioned that every time an invader came and successfully invade India, there was a difference in technology. Sometimes they knew how to ride horse. Sometimes they knew they had a better gun, better weapons. So the point is, if we got independence, but to keep independence, we have to do good science, to disable missiles of others, to fight with the others, just to, even if we are a peaceful country, to keep our boundary intact, we need to do a lot of science. So probably that our politicians understands better, and that's the ratio in the budget is such a way that the science budget is shown, but there are all these budgets never decide the fate of a war. So if we look at the Second World War, so it's much decided by the cryptographers. So Polish cryptographers broke Hitler's code. So they were mathematicians. So just paying to defense will not always save the country. Sometimes mathematicians will save the country. Sometimes cryptographers will save the country. So there are many facets of security, and the notion of security is changing. Because I personally work on quantum cryptography, I know that how things are changing. And so, and the next, if something happens, means that security will not come only from the guns and missiles. There will be many other facets of security, and many things will come from this, our development in the cyber world. Anyway, coming back to the challenges, the population is increasing. So that's the left-hand side curve is showing. Carbon dioxide emission per capita in India is increasing exponentially. Whereas gains and losses in forest, if I look, there are many states, Arunachal Pradesh, Manipur, Mizoram, where the forest cover is reducing. Again, the amount of land in which agriculture happens, that has been reduced considerably over the years. So now, as mentioned in the previous talk, we need our I dream and they make, means like we have to find out solutions, optimization solutions, so that more production can happen, yield will be more with the less amount of land. But deforestation is a bigger problem. So even if the farmland is reduced and we make a vertical farming, things will not be that disastrous. But the flood model has been changed. So the way Professor Shah tried to model flood, and when as a physicist I tried to model flood, so the parameters increases, and eventually a very important parameter is that the forest cover is reducing, and then many things are happening which are not streamlined. Just like you all know, the flash flood. So modeling becomes very difficult unless forest cover made static, or weather predictions will only be possible when there is a kind of stability in the forest cover. So there are several challenges. And as I mentioned, that often we become emotional about the discussion on India. So I often face a issue, means like we are now establishing a lab, and some colleagues we were in a meeting in Turin, and a colleague told me, great to know that now Indians are doing experiments. So I just answered that, I guess you heard about Raman and J.C. Bose. So they were experimentalists in India, but experiment is, and who did very good experiment in pre-independent era, but even now we lack in experiments. There are very good theoretical physicists, means, or in theory we are doing pretty well, but not in experiment. So experiment at a larger scale need to be done, and for that the labs in colleges must be improved in the beginning. So I dream that when there are colleges where there are state-of-art labs, students become interested in working in hand, and then they implement that. That will lead to Make in India startup. So things are all connected. Things cannot happen in an independent manner. Now, we dream of doing science and changing policies to invert these graphs through SMT. So this, what graphs are these? So these are showing import-export graph. And this is connected with my experience of developing my lab. So I just mentioned that in my lab, there is only one optical bench and 3 wooden boxes, which are made in India. Everything else are exported. So export is a big component. And sorry, everything else is imported. So import is a very big component, and a lot of duty is going on in that. So we are not even making small glasses, mirrors, reflectors, half-wave plate, quarter-wave plate. So I dream that there will be a time in 25 years or 20 years when we'll have everything Make in India in our lab, and we'll become exporter instead of importer, and the length of this, height of these graphs will just interchange. So now, almost at the end, I just want to talk about some other dream, but I'll start with what if. So I dream of a scalable, fault-tolerant quantum computers. So a quantum computer will, so ultimately, mathematically, or from the perspective of quantum computer science or physics, most of the problems are actually optimization problem, and that's true for the problems in real life. So if a scalable quantum computer is built, much effort is on that, and national mission is also in the way. So then many of the problems will be done in a much faster way than the existing supercomputers can do. So many optimization problems will be solved, be it drug designing, be it portfolio optimizations in a market, be it risk calculation for a insurance company, weather predictions, and so many other things. And at the moment, we have 50 qubit quantum computer, but we dream of 1000 qubit fault-tolerant quantum computer or so. If superconductive materials are discovered at room temperature, so I wish that all these discoveries happen in independent India or at par with the others. So if the superconductive materials at room temperature and normal pressure is discovered, then there will not be I square RT loss while the power is coming from a power station to my household. And then the requirement of energy will be much less. Not only that, maglev, the trains which are levitated and high-speed trains will be very common. The distances will reduce and the fight for resources which leads to energy, be it oil, be it coal, will be reduced. And probably with this, and if solar cell become extremely efficient, say greater than 80% efficiency under one sun global illumination. So right now the record in the lab scale is 39.5%, but that's in lab scale, not in reality. So if solar cells have become very efficient, we have room temperature superconductivity. Probably no country will invade another country for oil or just to have access for the oil pipelines or something like that. So world will be a much better place. Number of plants increases exponentially on the earth. I already told about the cover, and light, water, and land pollution, and then illiteracy and malnutrition reduces exponentially. That's the biggest dream of a scientist or anybody. Patents on essential medicines and other essential products become illegal. So probably I dream of a time when my research is not copyrighted by publishers, other agencies, and it becomes free to use at least the medicines, vaccines. But the question is, if that becomes, who will pay, who will do the initial investment for the discovery? So that's the conflicting questions. I don't know the answer, but I believe or I dream that the patents become free. Unconditionally network is built. So this is the thing where we work. So at the moment, everything is going digital. And if I can hack your system, suppose you are going by a self-driven car, and if I hack the systems, I can instruct the car to hit another car or a lamppost, and I can do a kind of e-murder. I can hack your account. We can do so many things. So we are looking for unconditional security, and that's a requirement in the world which will be governed by IoT. But the question is, when it will be completely unhackable, the government agencies which are doing investigations, they will also be in trouble. So there are conflicting questions with the dream that if we can really achieve unconditional security using quantum cryptography, whether in how the investigation agencies will work. Then there is something, a dream product called gravity detector. So there will be a small detector which will be able to map gravity. It's just like a thermal scanner. So in the quantum technology, it is predictable. So everything is not going to have a good effect. So gravity detector will be able to map submarines. So if the submarines are mapped, the power imbalance will be much effective, because now nobody knows where is my submarine. So a country which has 3 submarines and a country which has 100 submarines are almost equally powerful, because nobody knows where are those submarines. But with a gravity detector, it will be possible to detect those submarines, and then imbalance in the power will come. But this is probably unavoidable unless we come up with a shield, but physics does not allow me to make something called gravity shield. Now, we're talking about quantum cryptography and unconditionally secure thing. And the China has made much news, and we are trying to make, we have a strong satellite program, satellite-based quantum communication. But these satellites are put at the low Earth orbit. So they are about 600 kilometers from the Earth. And we have missiles which can destroy this satellite. So another dream is to make satellites which will be protected from missile. So that will give me the dream quantum communication network. So final remark, it is often said that science has no boundary. And people say that the earth was, nature was created the earth, there was no boundary, no country. But in reality, we cannot think of such thing. So there will be certain, means Newton's law will be used by everybody. A scientific discovery will be discovered by everybody, but there will be boundary, there will be countries. And we physicists frequently solve boundary value problems. So though artificial boundaries will remain and define countries, in order to keep the boundary, we have to do well in natural and to protect our natural resources from. Now in this era, nobody believes that somebody will come and take over a country, but rather there are many other kind of invasion. And if we want to get out of them, if we want to make our independence strong and vast and wide, we have to do well in science and technology and become independent in science and technology as well. So I'll conclude not only my talk, also the formal or technical part of this meeting with a Tagore's poem. So the left-hand side is in Bengali, but many people don't understand Bengali. So I just read the few lines from the translation. This translation is also done by Tagore in Gitanjali. Where the mind is without fear and the head is held high. So the Bengali lines are Chitto jeta bhoy shunno, Uchcho jeta shir. Where the knowledge is free, where the world was not being broken up into fragments by narrow domestic worlds, where words come out from the depth of truth, where tireless starving stretches its arms towards perfections, where the clear stream of reason has not lost its way into the dreary desert, sand, dead habit, where the mind is led forward by thee into ever wandering thought and action, into that heaven of freedom. My Father, let my country awake. So I wish that with the science and technology, improvement in science and technology, we move to the heaven of freedom and a land which is just like what Shah and Tagore dream. And I wish that we, the fellows of NASI, can contribute a bit to that. So with this, I'll stop, and I'll also request Dr. Neeraj Kumar, Executive Secretary NASI, to say a few words and also to recite a poem.
Thank you, Professor Anirbanji, for a very nice and comprehensive talk within a very short period. It's really taking science towards the self-sufficiency, and which was told today itself by our Honorable Prime Minister, that हमारी मानसिकता में जो गुलामी है वो खत्म होनी चाहिए. In his today's talk, he emphasized this, that we should come up all the obstacles and try to be self-sufficient with our own endeavors, setting aside the particular British culture and all that. And if you'll see about the National Academy of Sciences, for that I'm not talking specifically about the 75 years back history, but 90 years back history, when the National Academy of Sciences was founded by our beloved Honorable Professor Meghnad Sahaji. As he was a great patriot, why he founded this academy after so many things which he did for this nation, especially regarding the modern astrophysics and all that, for which he was called father just after his publication in the Royal Society of England. So he turned himself into a social as well as scientific activist. How? Because he wanted to solve the problems of the countries, and that was the first step which was taken by him to start this academy in 1930, with the aim of science and serving science and society. And even after going back from here, he mainly depended on the magazine, which is Science and Culture, and wrote many articles. And in last 20 years, so many articles were written in that Science and Culture, and they were specifically on the problems of the society and the nation and how we could solve them with the endeavors of science. Like you talked about the Damodar Valley project. Not only that, Damodar Valley project, but the energy was the main emphasis in Saha's many articles, which took that we should be self-sufficient in energy. And that is not possible with the small industries. That is possible only with the heavy industries. And we should think, we should plan the things. And that is how the planning in India also started with that. It was Saha who mooted the idea of planning with the Damodar Valley and the energy projects, and which were published in the Science and Cultures many times. So in about 20 years, more than 2,000 articles were published, and which were mainly on the problems of the society and the nation and how we could solve these problems. So starting this academy with only 19 fellows and 57 ordinary fellows, we can just think how we grow and how we have attained this self-sufficiency in our own dream. That when Saha founded this academy with the Science and Society endeavor, and he was helped by many, like you can read them about Khoshu, Menon sir, and Qasim, Professor Swaminathan sir, and here in the Allahabad, Professor U.S. Srivastava. Actually, during the period from Silver Jubilee to the Golden Jubilee, the academies passed with many vicissitudes, and there was many ups and downs. But again, after the Golden Jubilee session and the Platinum Jubilee, Diamond Jubilee session, these people who actually took this academy as a national forum for expressing their ideas and trying to mitigate the problems of the society. And Professor M.G.K. Menon was the main person who started this in the new era of this Science Academy. And Professor Khoshu, Professor Qasim, Professor Swaminathan, Professor U.S. Srivastava joined at that time, and which the tradition was then followed with Madam Manju Sharma ji, Professor Kakotkar, Professor Akhilesh Tyagi sir, Professor, our present president, Professor Ajay Ghatak sir, Professor Kasturi Rangan ji, all of them now contributing and contributed a lot for the development of this academy in general and the science in particular. Actually, if you'll go talk-wise also, if you'll see how Madam Manju Sharma ji has, in very briefly, gave details of how this academy grew and how many types of programs, varieties of programs for the science and society we are taking up under her guidance. So these all programs are nothing but to make the India self-sufficient, to light the lamp of knowledge and to spread the knowledge, disseminate the knowledge all across the country through the academy and its 22 chapters. Now this academy is the largest in its base, more than 3,500 fellows and members and 22 chapters. No academy has such a large base. And all the 22 chapters are almost active, and they are doing more than 400 programs in 365 days. We are not reporting all in our annual reports, but it is a fact, and which is sent to us through the chapters annually. For last more than 10 years, we are having the annual congregation of the chapters also, specifically because we want to spread and disseminate the knowledge of science and cultivate the scientific temperament all across the country through the endeavors of the science and the chapters and our fellows and the members who are really doing a lot for this academy. And you will see in science society, actually the program, if you just think, go back to the 1930s, Neil Ratandhar was deeply, keenly associated with our academy. Actually, he donated the land on which the academy's building is situated today. What Neil Ratandhar did at that very time, he started Professor Tyagi sir was just telling about the soil and all those things, and also the stress-tolerant varieties. Actually, all these things were started at 1930 by Professor Neil Ratandhar when he mooted the idea of establishing a soil science institute for the upgradation of the soils. And it was the first in Asia. Not only that, several other presidents of that time, like Birbal Sahni. Birbal Sahni was the only president who was nominated and who was elected twice as the president of this academy. Why? Because his link with the society and his link with the several experiments, due to which he also established the Paleobotany Research Institute. All these were related with the scientific solutions to the societal problems. So this academy has its intrinsic quality and qualitative nature in itself to promote science and culture in all the societies, in all the spheres of the life of India, our beloved country. So we, during our 75 years of year, if you'll see, Professor Ghatak sir also narrated in very brief almost the complete history of last 75 years, the growth of science with all the space and everything. But how we grew, without these academies, especially this academy, which was given the role of science, connecting science to the society. INSA was founded by the same founder, Professor Meghnad Saha, 4 years back after this foundation of this academy. But the role of that academy was basically to link with the other countries and the scientists of the other countries abroad, international collaboration. Professor C.V. Raman founded the third academy, which was mainly focused on the publications. But this academy has only a specific role since its inception in 1930, that this academy is leading towards for the problem-solving role of the societies. And many things, many ideas which are generated, it works as a think tank, gives many solutions, gives many ideas on which the people or the government take those ideas to take it forward. And I would like to say, if this academy is a think tank, Madam Manju Sharma ji is a thinking tank. She always thinks about how to go with the several problems and several societies, many endeavors where we can directly link with the society and do many things for the society. Professor Akhilesh Tyagi ji, very nicely, sir has a very huge experience and knowledge about the stress tolerance varieties and the genomics of the rice and wheat. And he emphasized how to solve the problems of the society with the food. and why it is necessary to promote such genomics. And when I just recall when in 2011, all 6 academies worked about that and thought about the genome sequence and all that, there was a criticism. But now again, we are at the same platform. We are working for that. Only genomics can solve these food problems. And Professor Subhra Chakravarti ji also told about that. So all these things which we are taking forward are basically the need of the hour, about which our Honorable Prime Minister is also talking in the terms of sustainability. But how this social sustainability could be achieved, that could be achieved only with the means and tradition of science and high science, good science. And as Professor Anirban ji, first of all, I would like to thank him for organizing this workshop within a very short period on the instance of Madam Manju Sharma ji. But it was very much needed on the concluding function of the 75th year of our independence and Amrit Mahotsav. It was very much needed. I'm very much thankful to Madam as well as Anirban ji and our Honorable President. Not only that, Anirban ji emphasized the role of the physical sciences also. And if you see the Saha's literature in the science and culture of 1935 and onwards till his death, 1956, you may see there are several literature there about the energy, about the quantum, and how this all could solve the problems of our Indian science and society. So this is needed to recall our memories. It is needed to have the sense of accomplishment, which is very much needed for the inspiration to go ahead. And if we will see, here I would like to mention that NASI staff also, especially I would like to say a few names. My old staff who have now retired: R.P. Tripathi, I.D. Shukla, A.K. Sahai, who have retired now. They are not with the academy for last 10 years or so, but they did a lot during the Renaissance period of this academy. I will like to call it a Renaissance period because after the Golden Jubilee, it was the Renaissance period. And what we are here now is because of the enormous contribution of our past presidents, president, fellows, members, and our such dedicated staff. Even present day, if you'll see Pavitra, Dr. Santosh, A.K. Shrivastava, Bhanu Pratap, many of, even some of the assistants, if you see, like Ankit is there, Raghavendra is there, Naveen is there, they all are contributing a lot and they need your help and cooperation as well as inspiration from all of you. You are elders of this family. So with the last word, as I was told to just recite a poem also, which I have written today, just now I have written it. आजादी का इतिहास वर्षों पुराना है, आजादी का इतिहास वर्षों पुराना है, बलिदानों का हिसाब मर्म स्पर्शी यादगार एक खजाना है, बलिदानों का इतिहास मर्म स्पर्शी यादगार एक खजाना है, पर आज की उमंग में मिला है उनके खून का रंग, पर आज की उमंग में मिला है उनके खून का रंग, बस तमन्ना इतनी है अब, बस तमन्ना इतनी है अब कि हम उनका सम्मान करें, कर बलिदानों को याद, उन्नति के पथ पर जीत का अभियान करें, जीत का अभियान करें. जय हिंद.
Thank you so much, Neeraj. Before Anirban, can you hear me?
Yes, you are audible.
I'll just take 2 minutes, not more than that. We are already late for time. When I thought I should mention before I request Professor Anup Ghosh to make his concluding remarks and formal vote of thanks, I thought I should mention that that when Professor Manju Sharma suggested that we organize this event, I was really very apprehensive as to how will this event go and with such a short time. But her vision and her commitment to the academy, and as Neeraj said, that really the Academy has made tremendous contribution with such little staff, 17, 18 people. But I would like to express my deep sense of gratitude to Professor Manju Sharma for thinking about this event and for the excellent talks that we had heard. By each one of you, I have to name each one of you for the excellent presentation. I have learned a lot. And my only regret that I have is that the number of participants have been less and not many very young people are there. The dream that Anirban mentioned, that would be the dream of a young 25-year-old person also. And he or she should listen to that. And therefore, I would like to suggest maybe an identical program if Shubhra could organize in her laboratory with participation of the younger people, and make sure that the young people participate and also speak. What we have heard today is really, really important that each one of the younger generation hears that. And of course, it is on YouTube, but none of us have the time. The younger generation will not have the time to listen to all the brilliant lectures that we heard today. So maybe we should have an in-house actual physical meeting when the COVID goes away, and with a greater participation of that. I will not take more of your time, but thank you, Dr. Manju Sharma ji, for your initiative. Thank you so much for that. Anup, your floor.
No, thank you. Thank you so much. And after Neeraj ji and what Professor Ghatak you said, I have nothing much to say. We are all indebted to all of you. It's a wonderful, very useful, and this is the program which is needed. And I'm very, very happy that we could organize in such a short time. About all in all, it is all of your guidance, and Neeraj ji said, that we could come up with. I personally benefited and learned so much from this program and all that. I just take one quote, what our first Prime Minister, Pandit Jawaharlal Nehru ji said, that science is not merely an individual search for truth. It is something infinitely more than that if it works for the community. I think we address all of them through all of the talk. So we are particularly very, very thankful, indebted to Madam Dr. Manju Sharma ji with such a opening up with this talk. Everything has been told in detail by Neeraj ji. Dr. Paramjit Khurana talking about the women in science. Dr. Akhilesh Tyagi ji and Dr. Shubhra Chakraborty narrating. Both of them are so, thinking alike. You can see that the thinking alike. They're bringing those points which are actually matching each other's, and the much needed thing for our nation, for our community. And all the 4 points I was learning, I've noted it down, and how the carbon footprint requirement, how the nutrition requirement, and all that which we should do, and it gave a thing. And obviously Anirban, how he puts the dream that he thinks dreams for all of us, that what we look into it. And so we are personally very, very thankful to this program. As Professor Ghatak said, we look forward to more such program with wider presence and in a larger environment. And we have a lot more. We are very, very enriched today, and this should be going. This should be going to the newer generation, younger scientists. They shouldn't even we get excited hearing this now. When I see that whether I was 10 years younger to take this work and again go forward with this kind of work. Last, but I'd like to personally thank Anirban. Yes. Anirban, in a shortest possible time, you have put together this program. We're very, very thankful to that. And I think we will look forward to more program. Anirban, hats up to you. Thank you. To call everybody to everybody's time and all that in such a shortest possible way, and it is very nicely done.
Thank you, Professor Ghosh.
Thank you very much, and thanks to everybody.
Now the last and most important part is that we'll conclude this program with the national anthem. So I request everybody to unmute themselves and
stand up.
Madam, you start. Adhinayak Jaya He,
Jaya He Bharat Bhagya Vidata Bhava Sindhu
Utkalavanga Vindha Himachala Yamuna Uchala Jaladhitaranga Tava Shubha Name Yave Tava Shubha Name
Gahe Tavu Jaya Gata
Jana
Jana Gana Mangaladayaka Jaya He Bharat Vidata
Jaya He, Jaya He,
Jaya Jaya Jaya
Thank you all. Thank you all.
Thank you all.
Thank you, Anirban. Thank you,
And
Neeraj.
can I request everybody to switch on the camera once, and then we can take a group photograph. Because
Anirban, one thing, just what Professor Ghatak said, that NIPJ, I think, is a second home for NASI, and any such program that we would take, NIPJ will be very happy to do that.
Thank you. We are missing today Professor Anurag Sharma, who is the chairman of the Delhi chapter. Unfortunately, he's traveling right now. So we will request Professor Anurag Sharma and Professor Anirban Pathak and Professor Shubhra Chakravarti, along with Madam and Neeraj, to organize. Really, I would like all the younger generation to listen to what Professor Tyagi, Professor
so I
Purana.
just want to add that means more or less equal number of people were in YouTube also.
Oh, that's wonderful. That's good to
So
hear.
some students may prefer to join in YouTube instead of Zoom, but there were people in YouTube, but not very large in number.
Thank you, Anirban. इसके बाद lunch भी तो होना चाहिए ना, तो
Yes, because a virtual lunch for virtual meeting.
Thank you all.
Okay, thank you everybody. We have taken the photograph and
Please don't forget what I have told you.
Yeah, madam.
I said don't forget. Please.
No. Tomorrow, sure, madam.
Itself
Sure, 100%, madam. Okay.
Thank you, madam.
Thank you, madam. Thank you, everybody.
कैसे हैं आलोक, आप ठीक हैं?
बिल्कुल ठीक है मैम, थैंक यू।